Good afternoon. Today we're going to be talking about instantaneous velocity, which is the velocity at an individual single moment in time as opposed to an average velocity over an interval of time. And we find it by making h as close to zero as possible. But if you remember the difference quotient, if h is zero in the actual formula, then that would be undefined. So we don't want that. So we want it to be as close to zero as possible. So for example, down below, think about this line here. And if you were at this particular location, that's not very dark, if you were at that particular location in time here, and you were trying to find the actual slope that you were going, it's going to be different than the slope of that secant line, because those dots are so far apart. If you were actually at this location, think about your actual slope. I mean, you're actually going uphill at that point, even though the average slope on that section is still negative. So if we shrink the h, so the h is the distance between the 2 points. If we shrink that down, we should get a more accurate secant line. This would be a little more accurate for where we are at this individual point in time or at this point in time. Those are a little more accurate for the actual slope. But if we can get those h's so close that they're essentially the same place, then we get this. And this is a tangent line. A tangent line is a line that hits the graph in one location only, not in two like a secant line does, but in just one spot. And that would give us our instantaneous velocity if we could find that. So that's our work today. We're going to be trying to find that number. All right, so let's look at this particular example. We're going to consider the position function s of t equals negative 16t squared plus 200t. Right? That would be Earth's gravity, the negative 16, and then our initial velocity, 200. So something's moving 200 miles per hour, feet per second, something like that. So complete the following table with the appropriate average velocities in feet per second. Okay, so there's a unit of measurement. Then make a conjecture, which is an educated guess, about the value of the instantaneous velocity at t equals 2. So we want to know how fast is this thing moving exactly 2 seconds after we've launched it. All right, so we're going to follow this velocity average formula that we used yesterday. That's what this little reminder here is for. That's our average, or how we're going to find average velocity. And we're going to keep finding average velocity as our interval gets closer and closer to zero. So we've got a table here. The first thing we're going to do is we're going to find the interval over time, or the average velocity over the interval 2 to 3 seconds. So first thing is in this particular formula here, we're going to plug in our second time value, that's a 3, into the actual formula all the way back up here. And this is what you need a calculator for. If you plug a 3 into that formula, you end up with 456. All right, now you want to do the same formula, except this time plug in the first number in the time interval, the 2. If you plug that number in, you're going to get 336. Then your denominator, you want to subtract your intervals, 3 minus 2. That's going to get you 120 over 1, which equals 120. So the average velocity between 2 and 3 seconds is 120. All right, now as you go to find the rest of these, notice that the t1 number, the time 1 number, is always 2 in all of them, because that's what I really want to know, is what's happening at time 2. So that t1 number, the 336, that'll stay the same, and every single problem from here on out will use that number in its answer. So like, for example, the next one, you would be plugging in a 2.5 into that t2 number. So you would be doing the negative 16 times 2.5 squared plus 200 times 2.5, and I got 400. Now the denominator is a little smaller. 2.5 minus 2 is 0.5. So again, I have the 336 will stay the same every single time. So you're just doing two different parts. Then you're dividing. I went ahead and did all of these. So that next interval, your average velocity would be 128. For the next interval, your average velocity would be 134.4. The next one, we're at 135.84. The next one, we're at 135.984. So you can see those numbers are increasing, but the amount that they're increasing by is starting to kind of flatten out. So that's giving us the answer that we're going to need in the end. A reasonable estimate for the instantaneous velocity at t equals 2, well, I'd say that those numbers up there in that table seem to be increasingly getting closer and closer to 136. Whoa, that wasn't a very good 136. To 136 feet per second. All right, so that's how you do your work today. It's going to be a lot of calculator buttons, so I hope you have a calculator handy. But the work itself shouldn't be too terribly difficult. It kind of follows what we've been doing the last few days. If you have any questions, you know how to get a hold of me. Good luck.